Hey guys, and welcome to a brand new project update video. And in this video we're going to go over a few things. But just a quick note, the reason I didn't upload a video yesterday was because I got hit with 2 exams in one day, which was rather unfortunate. However, now that those are out of the way, I'll have a little bit more time here. So without further ado, let's go ahead and get straight into it. So I've been working a bit on Stardust Engine, and what I've actually gone ahead and done with Stardust Engine is that now it actually allows us to basically do better sprites onto the screen, including sprites with animated textures. I also put the PSP through a torture test where I decided to render about, 4,000 sprites on screen at once. Yeah, that didn't go very well, but still ran reasonably well at 20 FPS, and that was merely due to the fact that I had 4,000 draw calls. The poly limit was way underneath what the PSP can actually do, and I'm pretty sure that if I use a tile renderer, which is something that I'll be implementing later, it will be a lot faster and more efficient. But I also added an animation system, and if you've ever wanted to see what 4,000 polygons on screen all rendering the same animation looks like in different colors, here's the example. And yes, I know this is a rather ridiculous test of the PSP, but it's sort of a cool little thing that I decided to do just for some fun. Anyways, moving on past that, what I went ahead and did was I did a different little project here. This is an example of basically running assembly code on the PSP, which is a rather difficult process, and it took several hours to reverse engineer the way that SEE module info really works. But once that was done and that stub was configured, everything else ran as pretty much expected. Now, of course, the code doesn't actually have an exit callback, so you have to manually reset your PSP, but this works on an actual PSP and displays hello world to the screen. In the future, I hope to probably do a little bit more stuff with this, including actually adding the exit callback, and probably just doing some basic tests of input and whatnot. And one of the things that I've been sort of researching is basically how does a Jvm work, or specifically the Java virtual machine, and exactly how would one go about creating their own sort of bytecode system. So basically the Java virtual machine is the underlying platform which allows Java code to run, because Java code is compiled once into Java bytecode, which is run by the each and every single VM. The VM is then basically ported to every single platform, and that allows you to run the code pretty much anywhere you want to. Now this does have some pretty bad implications on speed, and it's nowhere near as fast as really like optimized C++ and stuff like that. It's still respectively faster than any sort of interpreted language would really be. It's a nice little intermediate just to go ahead and see what will really work. So given this, what I went ahead and did was I created a brand new repository called PSP Jvm, which is going to be a Java virtual machine on the PSP. This is purely out of my own interests, and I'm only doing it in my spare time, but I'm really interested to see how this works from a computer science perspective. So what this really would be doing is creating, a virtual machine that can read Java bytecode on the PSP. Alongside it would also be having to use basically the virtual machine. Alongside it would also be basically implementing a Dynarec to the PSP. This would be my first experience with creating a dynamic recompiler, and it would be an interesting way to see how it would optimize performance, especially ahead of doing an ARM9 recompiler for DEAMN. Given that Java requires quite a lot of basically standard libraries and things like that that need to be ported, that's also going to be a big concern, because if Java code takes up a ridiculous amount of memory, as it sometimes does on the main PC, it's going to be rather bad for actually writing applications in, and it limits the size of your applications. That way I'm also going to be having to look into the sort of garbage collection optimization, which is going to involve basically looking at some more modern algorithms and implementing them in order to figure out exactly how the Java virtual machine is going to take up the least amount of memory possible while still offering the same amount of features and code support. Hopefully we could get smaller Java applications running on the PSP, and this would be a really cool sort of demo of a brand new language being added. Language support isn't necessarily the biggest on the PSP, given the fact that we're only allowed the C and C++ compilers, but this is rather useful actually for the creation of more applications, and it might soon enough become a viable language. So thank you guys for watching. Please like, comment, subscribe, and I'll see you guys later.